Hello, this is Mario from Odeon. In this video, we will explain how to perform calibrated measurements. To learn how to perform measurements using Odeon's measurement system, we have another tutorial video. But if you need to measure the strength parameter G or STI, you will require a calibrated setup. The reason for this is because of the definition of G itself. It is the ratio between the sound pressure level produced at a receiver point in the room and the sound pressure level at 10 meters in a free field while using the same source. The problems with deriving G lie in practicalities. First, even though G is a relative parameter, it still requires measurements of SPL, which cannot be performed on a PC unless the signal chain was somehow calibrated with a reference SPL. The second is the impracticality of finding a free field where we can set the source and receiver 10 meters apart. However, it is possible to indirectly derive G using only relative differences of SPL. This requires to first make calibration measurements in a reverberation chamber or an anechoic chamber. The method using the reverberation chamber is called the diffuse-field method, while the method using the anechoic chamber is the free-field method. In the end, a set of correction factors are derived. These calculations are handled by Odeon. You only perform the measurements and give some input data regarding the reverberation chamber or the setup in the anechoic chamber. Finally, you perform measurements at the measurement site. Although these will initially give arbitrary levels, when you add the correction factors, you obtain G. And with a couple of extra settings, you get STI as well. However, typically, when you take the equipment from the calibration room to the measurement site, it is extremely important to perform the on-site measurements with exactly the same setup. This includes two things. The first is that you should use exactly the same equipment that was used to calibrate, even down to the same laptop and the same cables. And the second is that the gains on all devices in the signal chain must be kept unchanged. You do have the flexibility to change the levels within Windows and Odeon's measurement system. This is because Odeon can keep track of how much the levels were changed and compensates for that. But if you accidentally change the gain on any other devices in the signal chain, then your calibration is no longer valid, and your G and STI parameters will be wrong. To avoid that issue, Odeon has an alternative calibration method called two-step calibration, which adds one more specific measurement both in the calibration room and on-site. While this may just feel like extra work, it completely eliminates the need to keep the gains fixed in the signal chain, as well as the need to use exactly the same equipment. This extra measurement is performed at a very close distance to the source. This is done in order to get a clear recording of the direct sound before the room reflections also arrive at the microphone. Odeon will identify the direct sound in the recording and cut away the reflections that arrive later in time. In both rooms, this direct sound must have exactly the same level. So, by comparing the direct level recorded in both rooms, Odeon derives the set of necessary gains to make it as if the source output was the same in both scenarios. Here, there's no problem regarding the near-field effects of measuring close to the loudspeaker. This is because we will get the exact same effect in both scenarios, so we will still have the correct differences. Odeon even derives different gains for different octave bands, meaning the signal chain can have different frequency-dependent behavior and still be equalized between the two scenarios. So, with two-step calibration, even the signal chain itself can be different. The only piece of equipment that should be the same, even with two-step calibration, is the source. To recap, the purpose of the diffuse-field or free-field calibration is to derive G according to its definition in an indirect way, while the near-source measurements are to correct for gain differences in the signal chain. By applying the diffuse-field or free-field calibration, together with the calibration from near-source measurements, you are left with only the actual physical differences of SPL per octave band required for G. In this video, we will focus on the diffuse-field method for a couple of reasons. The first is that it is typically easier to find a reverberation chamber versus an anechoic chamber. The second is that the diffuse-field method is more stable and gives more consistent results, comparing to the free-field method. Part of the logic of the diffuse-field method is calculating the power of the source, and from it, the SPL would produce at 10 meters. The full derivation is explained in our application note on impulse response measurement calibrations. You can find it on our website odeon.dk. Learn Application Notes. We mainly recommend to perform calibrated measurements using two-step calibration, so we will explain that method together with the diffuse-field method. There are various measurements to perform: the calibration measurements in the reverberation chamber, the near-source measurement in the same chamber, the on-site near-source measurement, and the normal on-site measurements. The near-source measurement in the calibration room will be referred to as the second step, as in this being the second step of the calibration. The near-source measurement on-site will be referred to as the in-situ correction. You can perform the full procedure in different orders. You can first create the calibration file with the calibration measurements in the reverberation chamber, the second step measurement, and the in-situ correction. Odeon can then make it the active calibration file, meaning it will be applied to measurements performed afterwards. Alternatively, you can make all the measurements first before combining them. This means you can even make the on-site measurements first, and later the calibration and second step measurements in the reverberation chamber. The calibration file can then be manually applied on already done measurements. For the diffuse-field calibration measurements in the reverberation chamber and the normal measurements at the measurement site, there are some guidelines you should follow. The height of the acoustic center of the source should be 1.5 meters above the floor. The height of the microphone should be 1.2 meters above the floor. Different microphone positions should be at least 2 meters apart. The distance of any microphone position to the nearest reflection surface should be at least 1 meter. No microphone position should be very close to the source. We recommend at least 6 measurements with different combinations of source-receiver positions. You can make up to 12 for high precision. For the near-source measurements in both the reverberation chamber and the measurement site, there's also some guidelines to follow. In both rooms, you will need to measure at exactly the same distance and exactly the same orientation. Typically, the reflection of most concern will be the first floor reflection. So, the source and microphone should be positioned such that the first floor reflection will arrive sufficiently later than the direct sound. For the distance, a good guideline is to place the microphone at a distance of 50 centimeters from the surface of the source. And the height of the acoustic center of both the source and the microphone should be 1 meter or more. We recommend to set the same height for both. For the orientation, make sure to measure at a loudspeaker orientation that you can replicate. This is to account for the fact that the source is most likely not perfectly omnidirectional, especially in the near field. Finding the same orientation can be tricky for an omnidirectional source like a dodecahedron, so try to find some sort of physical reference on the source. However, if you're measuring with the Odeon Omni, which is our own omnidirectional source for room acoustic measurements, this source is axisymmetrical in the horizontal plane, so you don't need to worry about the orientation. When saving the near source measurement, make sure to save the measurement with a file name that's easy to identify from the normal measurements. You can make the correction with only one near source measurement per room. However, you can also make several measurements and average them within Odeon for extra safety. Let's explain how to create the calibration file. To do that, go to the Tools menu in Odeon, then Measurement Calibration. Here, you can select whether to do diffuse-field calibration or free-field calibration. Again, we will focus on diffuse-field calibration. At the top of the window, you must specify the volume of the reverberation chamber. Then, click on Load First Single-Step Files. Here, select the calibration measurements performed in the reverberation chamber. You can select multiple files at once. If you have already made on-site measurements, be careful not to include them. Average arbitrary decibel levels and reverberation times will be derived, and from them a set of correction values. You can always toggle loaded files on and off. Notice that the correction factors update in real time. If you were doing single-step calibration, you could create the final calibration file now. However, remember that then, you would need to keep the signal chain gains fixed between the reverberation chamber and the measurement site. Instead, we will keep going for two-step calibration. We will go to the second step tab. Here, load the near source measurements performed at the reverberation chamber. You will notice that the Save to ST calibration file button becomes active, but we will explain this a bit later. Finally, go to the In-situ correction tab. Here, load the near source measurements performed on site. We can now save the final calibration file. If you are on site and have yet to perform the normal measurements, select to make this your active calibration file. That is, it is automatically selected when you open the measurement system. Still, always double-check the currently selected calibration file before performing measurements. Then, perform your measurements, and the calibration will be applied to them. You can always select a different calibration file or leave it empty. If you already had your normal on-site measurements before you created the calibration file, go back to Tools, Measurement Calibration, Assign calibration to existing measurements. First, select the calibration file. Then, select the measurements to which you wish to apply the calibration. By default, when your measurements are not calibrated, Strength G and other parameters that require calibration will be hidden to avoid mistakes. But once calibration is applied, Strength G and the other parameters will be shown. Also, when a calibration file is applied to measurements, it is permanently linked to those measurements, even if you close the measurement files and reopen them at a later time. At the bottom of the Energy Parameters tab, you can check whether calibration is applied to the measurements, and if so, which calibration file. You can unlink measurement files and calibration files at any time by going to Tools, Measurement Calibration, Remove calibration from existing measurements. If you plan to use the same source on various measurement sites, you can also create a two-step intermediate calibration file. This will only contain the calibration measurements and second step performed in the calibration room. Then, for each measurement site, you only need to perform the normal measurements and the in-situ correction, without having to repeat the measurements in the calibration room. This is because you can just use the same intermediate calibration file with different in-situ corrections. When you load the calibration room measurements into the calibration interface, the Save to ST calibration file button will be enabled. To create the final calibration file using the intermediate calibration file, you can either go to the In-situ correction tab of the calibration interface, or go to Tools, Measurement Calibration, In-situ Correction. You can also go to the In-situ correction tab from the measurement system. Then, load the 2ST calibration file. Make sure the file is loaded here, and values are populated in the first 2 rows of the table. Finally, load the in-situ correction measurement files. Then, you can save your final calibration file. If you own an Odeon Omni, it becomes even easier to perform calibrated measurements. This is because we can provide the intermediate calibration file for the Odeon Omni, so you don't even need to make any measurements in a reverberation or anechoic chamber. All you need to do is the on-site measurements, both the normal ones and the in-situ correction. You can download the intermediate calibration file from our website under Downloads, Odeon Omni Downloads, Pre-calibration file for G and STI. Then you go to In-situ correction, use the downloaded file to derive the final calibration file, and apply it to your measurements. You can learn more about Odeon Omni at odeon.dk/omni. Finally, for measuring STI with an omnidirectional source, the calibration process is the same, and there are only 2 additional settings that must be set up. You should go to Options, Program Setup, Measurement Setup. For the source power spectrum, you should click on the Speech ISO 3382.3 button, which will set up the spectrum of an omnidirectional source with a speech spectrum. For the background noise, you should manually measure it, for example with an SPL meter, and enter the values. Remember that the values should be entered here if no room is loaded in Odeon, but they should be entered in the room setup if a room is loaded. Also remember that the 63 Hz octave band is not needed for STI. This source power spectrum and background noise are applied at the time you load an impulse response and the calculations are done to derive the parameters. Therefore, you don't need to set this data when performing your measurements. Rather, you can set them at any time before loading your impulse response. Once you have done this together with calibration, you will get the actual STI values for your measured room. If you're measuring with an artificial mouth, there are some more considerations to take into account. For that, we would recommend to refer to the previously mentioned application note for more information. With that, we conclude this tutorial, and we hope you have found it useful. Good luck!